Now let's say that from some source we have 50,000 joules available to push an object 200 meters. So here's an object, maybe it's got wheels on it, maybe it's sliding across a surface. In any case, we have 50,000 joules available to push it 200 meters. So it's going to travel 200 meters. The dotted picture just depicts the object after it's moved 200 meters. The question is, what's the maximum force we can apply? For some reason, we need to push this thing 200 meters. We know how much energy we have available in our energy storehouse, in our batteries, in our gas tank, or whatever. We want to know what maximum force we can use over this distance. Well, the maximum force, now let's think about it for a minute now. If we exert a force over this distance, the work that we do will be equal to the force times the 200 meters. And that will be the energy that we lose. So that the maximum force that we're going to find would be the force that uses up every bit of energy at the instant this thing reaches the 200 meter mark. Okay, so the maximum force is going to deplete all the energy, so the maximum force will perform a 50,000 joules of work. Now, assuming that the force is exerted parallel to the displacement, we have then that the maximum force times your displacement is the delta W, the amount of work. So the maximum force is the amount of work divided by the displacement delta S. We simply divide both sides of this equation by delta S, and we see that F max is delta W over delta S. Then we easily conclude that the maximum force will be the 50,000 joules divided by the 200 meters. Since a joule is a Newton meter, when we divide it by meters we get newtons, so we find that the maximum force is 250 newtons. And here's a little note on the units. A joule is a Newton meter divided by a meter, and that gives us a Newton. And let's just zoom in on that just a little bit. Okay, so we see down here that a joule over a meter is a Newton meter over a meter. The meters divide, and we end up with newtons. Very important to do these unit calculations. Now we're going to get into the definition of kinetic energy. Kinetic energy is what we call energy of motion. And we got this theorem that says that if we have an object with a net force F net acting on the object, and the object moves through a distance or a displacement delta S, then the change in the kinetic energy, the object has original kinetic energy K E sub 0. What's the final kinetic energy going to be? The change in the kinetic energy is going to be the work done by this force, by this net force. Now the net force means the sum of all forces acting on the object. Okay? It's not just what force you are choosing to apply. It would be maybe the force you apply minus the force of friction that resists it, plus maybe some other force that's being applied to the object. It's the net total of all forces acting on the object. Delta S is the net displacement from this point to this point. Then, what we're saying is that the work done by that net force is equal to the change in the kinetic energy. Okay, F net is the sum of all the forces, as we've said. And when F net and delta S are parallel, then that means that the change in kinetic energy is the net force multiplied by delta S. And that implies that the final kinetic energy is equal to the initial kinetic energy plus the work done, the F net times delta S.